In this video, we're going to find the parametric equations for a line segment given an orientation. It says a particle moves from point A, which is 9, -6, to point B, which is -8, -9, in 4 hours at a constant rate. The coordinates are given in yards with respect to the standard xy coordinate plane. Find the parametric equations with respect to time for the motion of the particle. So if we're going from 9, -6 to -8, -9 in 4 hours, that gives us a rate that we can figure out pretty easily. So if we say that we are going to say the slope, I'm going to write this weird, this is the slope from A to B, and we're actually going to say the slope of the x variable from A to B is equal to, this would be 9 minus -8 over, so we started at 9, yeah, so 9 minus -8 over 4 hours. So we went from point A to point B. Let's see, actually I want to switch that around. Let's switch that around, right? Because it's always y2 minus y1. This was our starting point, this was our ending point. So we'll take our ending point, -8, minus 9. So ending point minus starting point over the 4-hour time. So I'm doing a slope of the x coordinate with respect to time. So this is like an x over t slope. So when I find this, I end up with -17 over 4 hours, and this is the change in x with respect to time. So if this is a change in x with respect to time, then my equation that I can write is that x of t, right, x with an input of time, is equal to the slope of this, which is -17 over 4 times t. And then what did I start with? Well, the x value starts at 9. This is my starting point here for x. And then this is my starting point here for y. So I'm going to write that that's starting points. So -17 over 4t plus 9 would be the equation I would get for x of t. Okay, so that's the first, this is the first parametric equation. Now I can do the same thing for y, so I'm going to say the slope for y is going to equal its ending point, -9, minus -6, all divided by the 4 hours as well. And this is change in y over change in time. So I end up with -9 plus 6, so that's going to be -3 over 4. And again, this is a change in y with respect to time. So then we can go ahead and write that parametric equation. So this would be y as a function of t. So y of t is equal to -3 over 4 t, because that's the slope that it was changing at per time. And then its starting point was -6, so it's -3 over 4t minus 6. So I have my two parametric equations. I want to find them in this list, and I get -17 over 4t plus 9, and then -3 over 4t minus 6. So these are my two parametric equations.